Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program today. We have the one, the only, Mr. Ralph Bond, who'll be joining us here in just a moment. And yeah, if you're new to this segment, you're in luck because we have some great stories, and we're really looking forward to kind of bringing them to you with everything that's been going on. As Ralph said before the show, maybe it. Obviously, this won't help with some of the recent tragedies, but hey, it could be a nice distraction. So everyone, we'll bring Ralph on in just a moment to talk a little bit more about that and talk about all of our stories. But computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes. Show notes are super important for this one. Ralph does an amazing job of putting these together. Dare I say, best in the industry. Putting these together with links, videos, articles, and relevant resources that you can find out more than what even we talk about. But he does an amazing job bringing you 4 great stories every single week. So everyone, let's go ahead and just get started. As I said before, Ralph Bond, he is of course our science and tech trends correspondent for Computer America and tech insider for the Mark Mason Show at KEX Portland, Oregon. Ralph, welcome back onto the program. How are you?
It's great to be back. And as you said, here today, we can give some uplifting and positive news to counterbalance maybe some of the horrible tragedies this week. But anyway, I just love doing this stuff. And Ben, by the way, I'll explain to the audience a little bit about what I do. So sure. As you know, I'm an aggregator of science and tech news features, and I find by monitoring a host of online news outlets, I kind of troll every day looking for stories. I look for important, and sometimes they're kind of wild and out there, goofy, wacky stuff, but a lot of it's pretty darn serious. And these are stories that don't usually capture mainstream press attention. That's one of the key things here. And I'm always on the lookout for news that gives a glimpse into where we're headed in robotics or medical technology, sustainable energy technology, transportation advances, space research, physics, and you name it. And what I do with each news item is present the essential points in a really digestible form. And I stress to our audience to check out the show notes you mentioned that you post for the links to the articles so you can dive deeper into the science and technology if you want to. So with that said, here we go.
Yeah, absolutely. And let's go ahead and jump into story number 1, a name that everyone should be familiar with, especially with Ralph being here. Intel. This is something that we've been following for ever since COVID. Obviously, it's still dominating the news cycle because COVID caused a bit of a chip shortage. It's still going on, and analysts say that hopefully, fingers crossed, by 2025 or 2026, it may be all cleared up. We'll have to see. But that led to a lot of head scratching and a lot of investment into changing things up. So that leads us into story number 1.
Yes. And I got this from the local, I'm here in Portland, Oregon area outside of Portland. There's the newspaper for us is called the Oregonian. So I got this story from the Oregonian, but then I also went to Intel's press room or newsroom online to get even more information. Headline here and talking about chip shortage and that sort of thing. Where are chips going? A lot of them are going into data centers. Okay, so this is related to that. So Intel is planning to build a huge research lab in Hillsboro, and I should have had in the notes Hillsboro, Oregon. And in fact, this is the campus that I worked at for many years. But anyway, they're planning to build a huge research lab in Hillsboro to make data centers more environmentally friendly. So this is a really kind of a remarkable story, and the illustration, the image of the architect's rendering of what this will look like is really cool looking building. Right. So here's the deal. Late last week, Intel announced plans to build a $700 million, 200,000 square foot research center at its Jones Farm campus in Hillsboro, Oregon. And Hillsboro is about, 18 miles west of Portland itself, roughly speaking. The new lab will conduct research aimed at ways to make data centers operate more efficiently, primarily by reducing their heating, cooling, and water needs. So imagine this whole giant building, its reason for being is research. Wow. I mean, this immediately caught my eye. So again, for some listeners who might not be familiar, a data center refers to a large group of networked computer servers typically used for remote storage, processing, or distribution of large amounts of data. So that's what we're talking about here. And this next data point in the articles and in the news release just flattened me. I had no idea. Data centers use about 4% of the world's energy. Let that sink in. 4%.
I had no idea.
Isn't that something? And more than a third of that 4% of energy is used just to cool the high performance computers. And they do this with energy hungry conventional air chillers. All right. Intel's new research facility will test a design for immersion liquid cooling. And this has been around for a while, but I didn't know anything about this. It's fascinating. So immersion liquid cooling submerges computers into a liquid. It's technically dielectric, by the way, a liquid that doesn't conduct electricity, but absorbs heat generated by the data center's computers. Can you imagine that? That's just so wild to visualize that. I'd love to see this in action. Maybe I'll get a chance to, since it's just literally a couple of miles from where I live. Someday I'll get a chance, I hope. Intel's, maybe when they open it, they'll have the press come, and I'll definitely jump in on that. Intel's data center immersion liquid cooling solution, which has the potential to reduce a data center's carbon footprint by nearly half, will be offered, and drum roll please, here we go, will be offered to the world as the industry's first open, easy to deploy, and easily scalable total cooling solution for data centers. Wow. I mean, they're just going to make this an open book of research to help anybody in the world. And you think to yourself, well, that's nice, but why would they do? Well, look, if you can make data centers more energy efficient, you're going to have more data centers. And that means more chips are going to be sold, and Intel's going to benefit. So there's a loop of benefit on this, but I still think this is a very, very commendable thing and super exciting. And if I can digress for a moment with a personal family note, my daughter works for Skanska, which is the gargantuan, huge international construction company. She's involved with processing and analyzing contracts and so forth. She doesn't work on the Oregon-based Intel stuff, but her company, Skanska, is going to be the construction company in charge of building this new huge research center. So kind of fun touch there too.
Yeah. And kind of to your point about hoping to see this, for everyone watching the video portion, this is actually kind of the, what they're talking about here. Went to the press release, and it's Ralph. It's not like one of those giant movie vats with like the goo and they drop stuff in it. It's unfortunately not as cool as that, which is what I had in my head. They look like, one looks like a half-size kind of like chest freezer or whatever, and it's connected with some pipes to another unit, which I'm sure would be like the cooling side of it. So it moves the liquid between the two. Very, very compact, and I can see why they said easy to deploy. This is really, really, really cool. And much to your point, just to give everyone a little bit more perspective on how much heat they generate. There are places in like Eastern Europe and Norway, and like places near the Arctic Circle up over in Europe that were actually renting out data servers to people's houses. They, as long as they had the proper electricity and the proper shelter. Oh my gosh, Ralph, they were generating so much heat. They were keeping people's homes warm. And, it's kind of a win-win because they don't have to pay for cooling because it's like, negative 10 degrees outside, and people's homes got heated, by just being there. These things generate a lot of heat. Yeah.
Yeah. That's a great story about people heating their homes. I love
it certainly can happen. And I'm sure anyone who has a big computer in their room knows how much heat these things can put off. But still, Intel to do this, this is just another step to sustainability. And the fact that, Ralph, that number or that statistic that you threw out, 4% of the world's everything, 1/25 of everything just goes to powering servers. That's crazy.
It's crazy. And by the way, to another kind of, I guess you could say, personal note, salute to Pat Gelsinger. This is, I think, part of the Pat Gelsinger culture And Pat Gelsinger is now the head of Intel. If you're
Right.
not familiar, that name's pretty famous now. And I had the honor and privilege of working with Pat several times during my almost 14-year career with Intel. But he's a wonderful person, and I can't tell you how happy I am as an Intel shareholder still and an Intel alum that Pat's at the helm. Great guy. You should learn more about him. He's a fascinating person.
Yeah, definitely a get in there and kind of work with Dave. Not just a business guy, but definitely someone who wants to improve the technology. That's right. And this is a step towards that. So,
yep.
Perfect. So that's story number one. Story number two, and gravity waves and gravity, and just, Ralph, we've come so far in the past couple of years with all the different kind of sensors and ways of picking up picking up different measurements that I'm honestly shocked that we can still find new things to detect and new ways to detect them. What's story number two? Yeah,
this is a good example of kind of the crazy wide range of things that catch my eye and I want to share with the audience. So now we're going from data centers to detecting earthquakes. So here's the story. It comes from science.org website, wonderful website. Scientists now say gravity signals could detect giant earthquakes at the speed of light. Okay, that's irresistible headline there. But first, let's set the stage for this news, kind of a little history lesson, I guess you could say, or at least where we are today. So today, devices called seismometers, we've all heard about them, are used to detect earthquakes by monitoring ground vibrations called seismic waves. So pay attention to this, ground vibrations. You're going to see why this is important as we go into the story. The amount of advance warning seismometers can provide depends on the distance between the earthquake and the seismometers and the speed of seismic waves, which travel less than 6 kilometers per second. Hold that in your brain for a second, put it over here, because you're going to see how this is important in the story as we progress. So on the positive side, of course, current seismometer networks can provide, depending on your distance ratio, seconds or even minutes of advance warning. There's nothing wrong with seismometers. They're great. Thank God for them. But here's the problem. Seismometers work well for relatively small earthquakes. But when you get beyond magnitude 7, and now we're talking about really incredibly serious earthquakes, an earthquake's ground vibration waves can saturate or overwhelm the seismometers so that they can't really do their job. So here's something that's interesting. Recently, a team of European and U.S. researchers announced that they found a new alternative solution for detecting big earthquakes beyond magnitude 7 that measures, instead of vibrations, it measures gravitational waves instead of ground vibrations. Gravitational waves. Okay. And this new technology more accurately detects earthquake size estimates faster by using computer algorithms to identify the wake from gravitational waves that shoot from a fault at the speed of light. The speed of light versus 6 kilometers per second, which is what we were talking about with the vibrations. Remember earlier in the story?
Yeah.
So it's just mind-blowing. Earthquakes result in large shifts in mass, and those shifts give off gravitational effects that deform both existing gravitational fields and the ground beneath seismometers. This is really geeky stuff, folks. You got to get into the article. If you're a real geek, you want to dive into this. It's pretty amazing stuff. And by measuring the difference between the existing gravitational fields and the ground beneath the seismometers, the researchers realized they could create an entirely new kind of earthquake early warning system. But there is a reality check here, and this is by admission from the researchers themselves. But the technology is not operational yet. So we're really getting, kind of a preview here, as it first needs to be tested, no surprise, on a real world giant earthquake in real time. So to accomplish this, the new detection technology model and system and so forth is being deployed to Japan to monitor a specific fault zone that has a history of generating major earthquakes. So it's going to be put into place into a zone or area in Japan that's very likely to have a major earthquake at some point. And then they'll be able to see if this really works. And if it works really great, then they can deploy it worldwide. But I just love this story. I just thought it was so interesting. And by the way, if I recall right in the article says that actually the research behind this was aimed at something else, but the researchers stopped and said, wait a minute, this could be applied to earthquake detection. So they didn't start with, let's come up with a new earthquake detection technology. It was something else. And then they realized, wait a minute, it could be applied over here in the real world, which I thought is just terrific.
Yeah. And really, I can imagine that a lot of people might think that earthquake detection can't get much better. I mean, we've been working on it for so long, but this is definitely using, the science of the day to improve how fast and how accurate we can kind of get.
Yep.
And I was, kind of looking at some of the strength and severity, like the difference in severity between like a 7 and an 8. And this article puts it, kind of in reference to kilograms of dynamite, because everyone knows how much dynamite kind of does. A 7, 20 billion kilograms of dynamite, an 8, 60 billion kilograms of dynamite, and then a 9, which, Ralph, I don't think we have like a measurable 9 that we've, ever really seen in human society, but that would be 20 trillion kilograms of dynamite.
Wow.
Early warning is, of course, one thing, but of course, severity and detection, all that kind of thing. Hopefully, they never detect anything too severe, but we have had some crazy natural occurrences lately. Japan won the other side of the ocean. I'm sure California would love something akin to this as well. So,
yeah.
Hey,
Ben, you mentioned. Sorry, go ahead.
No. I was just about to move on. Go ahead.
Oh, okay. Yeah. You mentioned dynamite, and it always makes me think, I think I have my history correct here. The Nobel Prize, Nobel was he invented dynamite, if I recall right. And he was so consumed with grief about how it was being used to kill people and for bad purposes, right? Because that was not his intent, that he established the Nobel Peace Prize. I hope I've got that right. Somewhere in the back of my head, when you said dynamite, it just sort of triggered that memory, but it's kind of an interesting side note.
I just a quick Google search, Alfred Nobel, most famous invention was dynamite. So there you go.
There you go.
Nitroglycerin and all that good stuff. But yeah, it's really, really amazing that they're able to use gravitational waves, because, if memory serves, they didn't even detect one of those until like 5 or maybe like a decade ago by now. Very, very cutting edge stuff. So love it.
Very much so. Right.
Yeah. So story number 2, story number 3. And, I'm about to go back to the dentist. I have some close family members and stuff going to the dentist. Ralph, I can't express to everyone how, we talk about cutting edge science and technology, and it's always so amazing. Going to the dentist is like stepping back just 80 years. Just like, we have a drill, we're going to scrape away those little bones in your mouth, and man, it's going to hurt. Like, there has been so little advancement in dental technology, though I will say, Ralph, you surprised me, because I was not expecting this turn.
Yeah, this is great. And by the way, dude, picking up on your commentary, where things have been huge advancements, and I'm not an expert in dental technology, but I think there's been immense advancements in the last, say, 30 years in terms of prosthetics. So for people who have terrible problems and they have to have whole new teeth and stuff put into there, the replacement business has been a huge step forward. But otherwise, drilling teeth and cleaning teeth is same as it's been for, God knows, maybe 50, 60, 70, 80 years. Yeah.
And without getting too personal, we took Craig to the dentist not too long ago, or we joined Craig at the dentist, and you're absolutely right. They can, if we decided to, he could have a mouthful of teeth like he was 20 again.
Exactly.
They can completely do that. But man, the price, let's just say,
sure,
$50,000, probably not, to take a lot of, tons of teeth out and put new posts in and wait 6 months and put, the cost of this, Ralph, and we talk about 3D printers all the time. I feel like, especially with you, we've talked about stories about, regrowing enamel and 3D printing teeth, and the stem cell research after reversing it from skin cells and stuff like that.
Yeah, man,
I can't wait to, the future is so promising. But man, today is so expensive. It's crazy. But hey, nanobots. What's up with that?
Okay, story 3, and the headline really doesn't do the story justice, in my opinion. It sounds like just as tiny robots could deep clean teeth, and okay, that's cool. Comes from Newsweek, by the way, but it's really much more compelling than that headline would lead you to believe. So, scientists at the Indian Institute of Science in India, of course, and a startup called Thera Nautilus have developed microscopically small robots measured in nanometers that can be guided using a magnetic field to help kill bacteria deep inside teeth. And remember, of course, a nanometer is 1/1000th of a meter. So these robots are super tiny if they're measured in quantities of nanometers. Holy smokes. But one goal of these microscopic robots is to help ensure the success of root canal treatments. And again, a little refresher here. Root canal treatments involve removing the infected soft tissue inside the tooth, called the pulp, and flushing the tooth with antibiotics or chemicals to kill the bacteria that cause infection. This is a big challenge when you do root canals. But the challenge is getting to bacteria in the dentin tubules, which are very small, hollow, microscopic channels that travel from the inside of the tooth, where the pulp is, out to the dentin, ending right beneath the enamel. So this is some dental geek out here for your second about these dentin tubules. Again, they're microscopic, little channels. So current antibacterial treatments can't go all the way inside the dentin tubules to find and kill bacteria. So this is a weakness we currently have. So to reach within the dentin tubules, the researchers designed helical, meaning spiral-shaped nanobots made of silicon dioxide coated with iron, which can be controlled using a device that generates a low-intensity magnetic field. And I'll stop here for a moment. Remember, in the past several weeks, we've had several stories in the medical community where magnetics are being used to guide things internally. So this is another really interesting example of it. So back to the story. These microscopic nanobots can then be injected into dentin tubules, and their magnetically guided precise movement is then tracked using a microscope by the doctor. And the new nanobot technology will soon, according to the article, enter into clinical trials. And it's going to be really interesting to see if this works out well. And to your point earlier, can they make this commercially viable, affordable within reason, and so forth? All of that's TBD, but I think this is really kind of a fun story.
Yeah, it's and you know, the pictures are always so helpful. I'm glad that you include them, and of course the article themselves have them as well. The shape of them, Ralph, really reminds me of another nanobot. I don't know if we've ever talked about this on the show together, but for anyone out there watching the video portion, I'm gonna kind of blow this up to max size. So this is an embryo, and this is a nanobot, Ralph, that's actually going. Just tell people, it's a nanobot that's going to pick up a sperm and deliver it to the embryo. And you can kind of see how similar it looks because, and you can imagine the scale of this thing, very, very tiny. It looks like a little spring for everyone just listening, and it actually delivers it onto it. Ralph, I'm curious if, like obviously this is two very different use cases, but yeah, this is very similar nanobots.
It sure does look like the same thing. And what amazing, how they got that video is amazing to me.
Yeah, that too. And of course, so just being able to deliver, antibiotics and drugs and stuff to very, very tiny places. Very cool. Not what I was kind of hoping for. I was kind of hoping for, just throw in a mouthful of nanobots and just kind of wait a couple of minutes and, spit them all out and then you're good to go. But no, close. Very, very close. We're getting there. Story number 3, story number 4, and this will be the last story of the day, but I can't think of a better way because, man, a Mars trip, you might know better than I do, Ralph. How long have we been talking about sending people to Mars? That's been a dream for decades.
Wow. Yeah. I mean, as soon as we got to the moon, which I vividly remember coming up from, I grew up in San Clemente, so we came up from the beach early so we could watch the TV and see the one step from man, that whole bit jumping off the lander. Yep. But I think right after that, people started to say, what's next? Can we go to Mars?
It's never enough, is it? It's never enough.
It's never enough. That's right.
So story number 4, we're going to talk about plans for hey, actually getting two people there. And hey, luckily it's not just waiting for Elon Musk. We can actually, NASA can do its thing.
Yeah, there you go. So the headline here is NASA recently previewed plans to send 2 astronauts to the surface of Mars. And I got this from futurism.com, which again is a wonderful website. So here's the story. And it's just kind of fascinating because this official, we'll get into this, just sort of was talking and sort of disclosed the essential ideas behind this mission. So recently, Kurt Vogel, that's Vogel, Kurt Vogel, NASA's director of space architectures, previewed what a future 30-day manned mission on the surface of Mars could eventually look like. Now, the qualifier here is, while many years, if not possibly decades away from actually happening, NASA's vision calls for a habitat spacecraft. This is an interesting, let that sink in for a second, a habitat spacecraft to make the months-long journey to Mars. And once in orbit above Mars, 2 crew members would remain in orbit while 2 astronauts would be deployed to the surface of Mars. And once on the surface of Mars, the 2 astronauts would have access to supplies sent to the surface beforehand via a, get this, 25-ton Mars lander. 25 tons. Wow. The 25-ton Mars lander would also provide surface power and mobility, as well as a crew ascent vehicle to return the 2 astronauts back into orbit later when their mission is over. Now, to spend up to an Earth month on the desolate Martian surface, NASA's Vogel suggests the 2 crew members could live inside a large pressurized mobile rover. So it's you can live in this thing. It's pressurized, but it's also a mobile rover that would provide habitation and allow the 2 astronauts to complete scientific objectives as well on the surface. And I encourage everybody, if you're interested, please use the link. Please go out and read and learn more about this from not only this source, but from NASA itself and so forth, because it's really a fun thing to sort of wrap your imagination around.
Definitely. And reading a little bit on the article saying that it would take 2 Earth years to complete, factoring travel times, 500 days on the surface. 500 days on Earth, I guess, long stay missions that could take 916 days. I'm guessing, like, travel time wise, it takes about 6 months. Or how long does it take to get to Mars? Is it like 6 months?
Well, let's see. It's multiple months. I thought they mentioned that in passing in the article. I'm trying to recall now.
But either way,
it would take a while.
Yeah. This would be actually one of my favorite movies. Was what was that? They sent that crew to Mars, and one of the guys stayed awake, and he was supposed to be in cryo sleep, and he just went. There was him and a chimp, and it was a whole Mars movie. Oh my God, I loved that movie growing up. That was like my favorite movie. I don't remember it at all. But anyways, so there's that, and I'm sure it's going to go a lot better than than that shtick movie did. But still, Ralph, you know this, I know this, everyone knows this, that whatever NASA plans, like whenever they want to do something like this, it takes 20-25 years to actually plan it, fund it, research it, do it, and then finally get it going. So hopefully it's faster than that. But yeah, the fact that we're even talking about people on Mars, that's a step in the right direction. Love it.
Yeah, it's pretty fun.
So with that, Ralph, we are absolutely done for today. And yeah, everyone, if you want to find out more, computeramerica.com. We'll have a link to, of course, all the show notes, all the articles, and of course, we'll have a link to Ralph's website as well. And if you go over to our YouTube, we have all of Ralph's shows in one category. You can just look up Ralph, and there's a lot more stories like this. All of them are timeless because, hey, they're cutting edge, and we love that about it. So everyone, until next time, Ralph as well. We'll catch you here next week, next Friday. Everyone have a great day. Bye, everyone.